So today we are talking about more logs, except they have a base of e. Do you get a log 5 that had a base of 10? I just didn't say anything about it. I didn't show it. All right, right now what I want you to do is shut your iPads. I want your full attention on what I'm doing right here. This has a base of 10. It's called the common log. In your calculator, can you shut the iPad, please? Just still waiting. Thank you. All right. There we go. This has a base, and if I wanted another base on it, I could have a different base on it. It would be completely different, but log would have a base of e. Do you remember what e is? E is about 2.718. All right. I'd like you to see what the difference is between log base 10 of 5 and log base e of 5. You need a graphing calculator. You wouldn't have to have a graphing one, actually, but a calculator. If you're using the graphing calculator, the e key is right above the divide sign. All right, if you put this on your calculator, I know you're going to type in log 5 over log 10. Just make sure you do the parentheses right. Calculator. All right, ZA, could you tell me what you got for log 5 over log 10? 0.698. Anybody get the same? Else get the same thing? All right, now, was there a faster way than typing in log 5 over log 10? Yeah, just typing in log 5. Because the button on your calculator is doing base 10 automatically. If you say log 5, you're saying log base 10 of 5. Just log means log base 10. Is there a faster way on this one other than typing log 5 over log e? Yes, there is. But you know what it is. All right, then you're going to learn something. This log base e is shortcut ln. You see it right underneath your log button. There's an ln button. Did you know that that was 4 before? It's for doing log base e instead of log base 10. So, type in ln 5. What do you get? 1.6 what? Thank you. And if you type in log base or log 5 for log e, yes, then doing it in base 10, and you would have gotten 1.61 again. Right, so the point here is that two things. Number one, are different, and it does give you a different answer if you have a different base. If I have a base of 10 versus a base of e, there are different answers. All right. Let's do another one. Log base 5, oh no, sorry, log base 5 of 5 to the second. And would you want to type that into the calculator, or could you just tell an answer faster than that? Just 2. Done. Boom. Because if these two are the same, then that one's the answer. You could set it equal to x, and then you go 5 to the x equals 5 to the second. And that makes it really clear that x must be 2. All right, a couple other little properties you should know. Log base 17 of 1. Answer. Boom. Should have it. 0, because if this is ever 1, then the answer is 0. Why? Because 17 to the 0 would equal 1. That's the only way it can work. It's the only thing that could be there. All right, so if this is a 1, this is a 0. On to the next kind. Not log base 9 of 12. What's the answer? 12. All right. And if you're going to remember only one thing today, log base 10 was common log. The new log is e, and we now have a way of writing log base e that's cut. What is it? ln. So whenever you see a problem with ln in it, I would rewrite it as a log base e. Because otherwise you see a problem like ln e, and you can see that on the SAT test, for instance. And actually, you could just type in ln and then the E button and hit equals, and it'll get the answer. But there's a shortcut way that's way faster. Anytime you see ln, just rewrite the ln as, throw that off to the side, base E. And now do you see what the answer is? What is it? 1. Because now these two are the same, and therefore the answer is the exponent on that one, which is just a 1. All right. Thank you. Let's say I had ln of E squared. The same thing as log base E of E squared, so the answer is 2. All right, how about this? What if you had E to the ln 4? What's the answer? 4. Because couldn't you just take out this ln right here and put in what? Log base E, and then this and this are the same, so the answer is that. All right, so you're getting the idea what ln is. All right, I'd like you to try a few. Open your iPad, get into marks, and try this. What if you had 4 ln of E to the 5th? Don't say the answer, write down the answer. And then billboard it to me so I can see what you think the answer is. If you learn nothing else today, you're supposed to learn one thing in this, to replace ln with something. So this answer is really simple. No calc. Yep. So turn it towards me. Show me what you got. Turn it. Be confident. You're right. Good. Now look at yourself. Good. Good. Looking for more. No, thanks for trying. Good. You got it written right. You just haven't finished it. Good try. It's just that you haven't finished it. You don't divide them. That 4 in the front is not being divided. You're getting a good start, but you haven't finished. Yes. Yup. Yup. Yup, 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 yup. All right, I'm getting most of you now. What happened here was this. Supposed to replace the ln. I'm just going to do a little quick forgery here with log base E. And then you realize it's 5. But a lot of people said the answer is 5, but it's not 5. This part right here is 5. So then what's the final answer? 5 times this 20. Okay. Let's try another one like that. E to the ln of 4. Give me an answer. Billboard it to me. People I didn't see last time, do it first this time. Yup. 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 I'm still waiting for some of you. Hurry up, please. Thank you. Good, good. As long as you're working on it, I'm okay. But yup, yup. Yup, 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 yup. Yup, yup, yup. All right, good. Everybody's getting this one. This one is log base. If these two are the same, that's the answer. So the answer is 4. Okay. There are some application questions that are going to have E's in them. And a lot of times this formula comes out. A equals P E to the RT. This is about money. If it's about money, what does P usually stand for? Principal. And what does principal mean? Hold on a second, I'm pausing. All right, so back from the interruption there. This is principal, which is like how much money. So let's say that the person is going to put $40,000 into some kind of an investment. Then the $40,000 goes there. The rate is how much interest rate they're getting. Let's say it's 8% interest. The time is how many years that you're going to put it in there for. Let's say I'm going to put it in there for 3 years. And E is a special kind of compounding. It's called compounding continuously. This is one of the reasons that E is cool. Put your iPads again for a second. E is cool because in nature you find this way called the natural log. You know what it was? ln. Okay, natural log is what that is. The natural log has a base of e. This number's found in nature and in math, like when you're doing compounding. There's a special this number, and I think is more interesting, is bacteria growing. You've heard of bacteria, haven't you? Imagine that you cough into your hand for a second. You're not supposed to just cough in your elbow, but cough in your hand. And you look at your hand. There's microscopic little bacteria that you can't even see that are like running all over the place, right? If you put that into a grow, like you put it on a petri dish and give it like basically a little food, the stuff will grow, and bacteria grows at a rate with a base of e. Y equals e to the x. This special number is found in nature all over the place, and different kinds of bacteria grow at the rate with a base of 2.718. So 2.718 is kind of like one of these weird numbers found in nature all the time. So same with Fibonacci. All right, it's also found in math when you do a special kind of compounding, not monthly, not yearly compounding, not daily compounding, but continuous compounding, like compounding all the time. Like anytime you can think about compounding it, it's compounding. Okay, so it's compounding continuously. This is a special formula. You don't have to memorize the formula. We give you the formula. But this is what it's for. E is just 0.718 still. But to figure out the answer here, you would type in, not the 40,000. Why am I going to do this blue here first? Because it's an exponent, and exponents have priority over multiplication. So you're going to type in e. Go ahead. It's above the divide key. To the power of. Or you would put in parentheses, just to be safe. So many mistakes are made for not having the parentheses. 0.08 times 3, end parentheses, equals. Once you got that, then you can times it by the 40,000. Why didn't we do this on the calculator? 40,000 times e and get that answer, and then put it to the power, because we'd be multiplying before a power. You can't do that. Powers have to come first. So that's why we did the blue part first. And if you did it correctly, what do you have? $50,849. That's good enough. And think about this in real terms. If you have $40,000 and you're earning interest, and it's been 3 years later, shouldn't you have more, like maybe 50,000? Yeah, that makes sense. Okay, so that's a application type question. They give you an equation, the red equation there, and you put the numbers in. All right, I'm going to back up a bit, and I'm going to have you on your iPad. I want you to solve this question except with different numbers now. I'm going to tell you in words, and you figure out where to. See, your great Aunt Tilly gives you $2,000. You stick it in an IRA that advertises that they do continuous compounding. The rate they're going to give you is 4%. And you're going to put it in there for 40 years. It's a long time. So you lock it up at 4% for 40 years. You had $2,000 to start with. Use your calculator. Figure out how much Aunt Tilly's gift has grown to by leaving it in there for 40 years. You've done 2,000. And then E is a number, 2.718. Use calculators right above the divide key. To the power of rate, 0.0, did I say 4%? Okay. And then the time was 40 years. If you put that in the calculator correctly, what did you get? Right there. Guy in the gray, not saying your name because we're on tape. Like that? 9906? 0.06. Can anybody verify that? They got the same thing. Lots of people did. So you're right. Good. So, 1,000 turns into 9,000. I got more details on that Ben Franklin example I gave you before. He did have them lock it up for 100 years. He gave to both the cities of Boston and Philadelphia, two of his favorite cities. He gave them a bunch of money. He said, I want you to get 5% on this money, and I want you to do it for 100 years. city did their best. They couldn't get 5% all the time because sometimes banks would pay that much, sometimes they wouldn't. So they just did what they could. They didn't always get 5%. His yes did grow pretty dramatically. I'll show you that. I've made up a little lesson on that. I'm going to show you someday. Just a 2-minute like real world example of math. But it was kind of cool because he gave the city a gift and said, "Don't open it for 100 years." I'm thinking about doing that in my family. Taking a bunch of money, not tons, but decent, sticking it into an investment, and leaving it in what's called a trust. Except I'm thinking about leaving it in there for 200 years. Does it always grow? Yes, it depends on the investment, but I would want to have it with a company. And a trust is something that is left behind where a person manages the trust. So that the person would be in charge. And if the bank ever goes, like for instance, let's say that bank goes out of business, the money's guaranteed by the government up to certain levels anyways. So they'd have to then take the money out of that bank and put it in a different bank and keep trying to get 5%. So let's just see what would happen if we did my example and sent 200 years, and let's say I put in $5,000. 5,000 bucks. 5% for 200 years. How much should that money be worth? And then I got to figure out who to leave it to is the complicated thing, because if I only had like one descendant, like blood descendant, that'd be simple. If not, I suppose I could say any blood descendants that are left can split it equally or something like that. Banks would not give you 5%, but if you haven't invested in the stock market, the its average over the long haul has been 9%. And so it's very possible that somewhere between investing it in bonds and stocks and maybe some in the bank that you could get 5% pretty safely over the long haul. So did it turn out to be a big amount of money? Okay, so let's see. If you did 5,000 E to the rate of 0.05 and then 200 is that's the thing that really jumps this up top. Okay, what did you get? Would you read me the digits, please? That's a lot of dough. All right. You didn't get that? Check what. Okay. All right. So if it is interesting, you think the 5%, 6% don't seem like much different. Would you just run this problem real quick and say we got 6% to 5%? And let's see how much more we'd have. Type in the calculator. You're going to be typing in the same exact thing except 0.06 times the 200 in the exponent. Did we have a bunch more? What do we have now? Front row. You did it last time, you can do it again. 81377 391. So I'm putting the commas in now. Holy smokes! From 110 million to 813 million, almost a billion. Look at the difference between 5 and 6%. Do you see why some people are willing to take more risk on their investments? Because they're willing to say, hey, I'm willing to risk a little more because 6% is way better than 5% in the long run. Look at how much difference. Yes, the more risk you take, the more chance there is you could lose the money too. So it's always a balancing act. You don't want to just stick it in a sock drawer because it won't grow. The 5,000 bucks will still be 5,000 bucks in 200 years. If you have it in a trust, nobody gets to spend it. Yep, it's just managed by the trust. And the person who's in charge of it, just like once a year or whatever, makes sure that, yep, is this still growing? And if it's not, maybe we should rearrange it a little bit, put more in stocks, put more in bonds or whatever. So actually over 200 years, you're probably talking about 2 or 3 different trusts are going to have to happen. So the first person say that they've managed it for like 15, 30 years or whatever. They hand it off to the next person who has to manage it for the next 30 years. Hands off to the next person. And a simple gift of $5,000, which is like the cost of a used car right now, could turn my family to almost a billion family 200 years from now. Just an interesting thought. All right, so there's a little lesson about E, and let's do some of the homework together. Everybody find the homework. You'll find it under today's date, which is 4-22, and it looks like this. Application and match. Yep, this is the one. And the first few, if you know what you're doing on the calculator, are super simple, because you're just typing into the calculator. I don't think you even need my help here. E to the fourth, you find it's right above the divide key. You put it to the fourth, yeah, get the decimal, bam, write it in. Okay, so those will be super simple. Let's go on to number 2, because these you don't have the calculator to do. Now, we have to trust you on this, but if you just type these into the calculator, you're not going to know how to do it on the test, so make sure you get what to do. What did I say to replace ln with? Log base E. And then I'm just rewriting the whole thing. And all of a sudden, it becomes really obvious. Oh, these two are the same. So what's the answer? -2. Yes? On the application problem, I think it's safe to say that we would let you use the calculator on any application problem, unless it says specifically in the directions. Okay. All right. My computer's got the blue ring of death going, so I don't know what that means. Can't be a good thing. Yeah, it's probably pretty accurate. All right, let's move on to, this is just a applications problem where they give me an equation. Those are always the easiest kind. Because if they give me the equation, all I got to do is take whatever number they give me and I stick it into the equation. That's usually what we're doing with these. Look at Chug. These aren't super complicated ones. So, let's try to figure out where to put what they give us. This models the average number of free throws a basketball player can make consecutively during practice as a function of time, where X is the number of consecutive days the basketball player has practiced for 2 hours. After how many days of practice can the basketball player make an average of 10 consecutive free throws? All right, here's the key. X is the number of consecutive days, and the function gives you the average number of free throws a basketball player can make. All right, so this is the free throws right here, and this was the number of days. And X was, told you that before. So now, 10 consecutive free throws. Where do I put the 10? At the very front. So I go, it goes right there. So I go 10 equals 1 plus 1.5 ln of x plus 1. Now, can I just type this all into the calculator? No, because it's got an x in it. Those evil teachers. So, first thing is, we're going to get rid of this, we're going to get rid of this, and then it'll get down to just the ln. And then, Mr. Server always said to read. So I'm going to do all of that. First I'm going to subtract the 1, I get 9. Then I'm going to divide this by 1.5. Divide it by 1.5. And that gets these two. Okay, and now somebody help me with 9. What is 9 divided by 1.5? 6? Thank you. So this whole left side then has become 6 equals ln of x plus 1. That looks a lot simpler. And then what was the thing I said to do? Replace the ln with log base e. So I'm going to go like this, log base e. And then still don't know what to do. Rewrite it. Whenever you're stuck on a log question, rewrite it. If it's a rewrite it as an exponential. If it's an exponential, rewrite it as a log. So I'm going to go e to the equals x plus 1. Rewrite. I'm going to go up here to do that. E to the 6th equals x plus 1. Ooh, my calculator can do e to the 6th. So you type in e to the 6th, and you get some decimal. Equals x plus 1, and then I'm almost done. X has to be subtracted 1 from both sides, and I'll have x alone. So if you can do e to the 6th, and then take away 1 from it, you'll have it. Are there solving calculators? Yes, there are. Yes, so you could actually just type this whole puppy into a solving calculator, or even, I think, you could type it into Wolfram Alpha, and it would solve it for you. Anyway, this equation, back to the beginning here, this red one, that equation, see if I can get somewhere where I can see it. Anyway, this red equation that's now got this green stuff over the top of it, that is the one. You know what? You can always solve equations, though, by graphing them. So you were asking, could you solve this with your calculator, like just directly? The only direct way, graph this, graph that, where they cross. Don't forget that. Always works. Every kind of equation, even logs. It works so well on the ACT test. Whenever you get an equation, once you've got it down to one equation, graph both sides, see where it crosses. That is a pretty fast way, as long as you know how to find where intersect is on the calculator. You have to know where second calculate intersect is. If you know how to do that, then that way of graphing both sides, seeing where the crosses, you can do that here too, since calcs are allowed. You could do it that way. All right. That's all I got for you for today.